Hello class, we're about to do chapter 6, lesson 5, algebra problem solving. We're going to go over the problem solving method for doing word problems, which we basically covered in previous chapters. So let's get right down to it. Okay, number 1, it says a number divided by 2 is equal to 12 less than the original number. What is the number? So with number 1, we will add x is the original number. Now we can use any variable, but I'm choosing to use x. So a number is x divided by 2 is equal to 12 less than the original number. So 12 less than the original number would be x minus 12. Now we have to go through and solve this for x. So first of all, we want to get rid of this fraction. So we'll multiply each side by 2. Now we can make this 2 over 1. These 2's will simplify out and leave us x. X is equal to, now we will have to do the distributive property, be 2 times x plus 2 times negative 12. So we have x is equal to 2x minus 24. Now we will subtract 2x on both sides. X minus 2x will be a negative 1x and is equal to negative 24. We'll divide each side by negative 1, and x is positive 24, which is C. So that took care of problem number 1. Now we move on to problem number 2. Problem number 2, it says for a fundraiser, Sandra raised 3 times as much money as Barbara, and Barbara raised $50 more than Matt. So basically, Matt is the key. So we start off with Matt, and then we go to Barbara. Barbara raised $50 more than Matt. So Barbara would be x plus 50, and then Sandra raised 3 times as much money as Barbara. So it'd be 3 times x plus 50. So now we have Matt is x, Barbara is x plus 50, and Sandra is 3 times x plus 50. Now, all together they raised $950. How much money did Barbara raise? So we have to add these 3 together, Matt, Barbara, and also Sandra. So now we could drop the parentheses here since they had a plus sign in the front. Oh, I'm sorry. I forgot to put down equals 950 because all 3 added together is supposed to equal 950. So here we could drop the parenthesis and we add x plus 50. Here we would have to do the distributive property, so it'd be 3 times x plus 3 times 5 equals 950. So this would be x plus 50 plus 3x plus 15. Oh, I'm sorry, plus 50. I don't know why I put plus 5. So this would be 150 equals 950. So that'd be 3 times 50, which is 150. Now, we combine like terms. We have x, x, and 3x, which will give us 5x. And 50 plus 150 is 200, equals 950. So we'll subtract 200 on both sides. So we have 5x equals 750. We'll divide each side by 5, and x will give us 150. Now remember, x is what Matt raised, but we're trying to find what Barbara raised. So we'll go to Barbara, which is x plus 50. So now we'll put in 150 for x, and then now we will have 200. So Barbara raised $200, which is C. All right, now we move on to problem number 3. it says the 3 packages below weigh a total of 15 pounds. So that means if we add all 3 packages together, they will equal 15 pounds. The first package weighs twice as much as the second package. The third package weighs 3 times as much as the second package. How many pounds does the first package weigh? Now everything is according to the second package. So what we would do is we would still put first, second, and third package. So the second package would be X because everything revolves around the second package. So it tells us the first package weighs twice as much as the second package. So that'll be 2X. And then it tells us the third package weighs 3 times as much as the second package. So that'll be 3X. Now we want to know how many pounds does the first package weigh. So with that, what we would do is this. We have to add all 3 of these values together. The first package plus the second package plus the third package is supposed to equal 15 pounds. 2X plus X is 3X plus 3X is 6X equals 15. Now we would divide each side by 6, and X is equal to 15 over 6. Now remember, X is the second package, but they asked us to find out how much the first package weighs. So what we could do first, let's simplify this. We could divide the top and bottom by 3, so that'll give us 5 halves. We could leave it as 5 halves until we actually complete the problem. So we want to know what the first package. Now the first package is 2 times X. So we'll do our first package will be 2 times 5 halves. So now again with our first package, we would do 2 times 5 over 2, put that over 1. These 2's will simplify out, and your first package would be 5. So your first package would be 5 pounds, which is C. Now, we move on to problem number 4. It says here that Hannah scored a total of 170 points on 2 math tests. The score on the first test was 6 points lower than the score on the second test. So we have the first test, second test. Now the first test is dependent on the second test. So we'll make the second X, and the first test is 6 points lower than the score of the second test. So we'll do X minus 6 for the first and X for the second. Okay, how many points did Hannah score on the first test? So we know adding these 2 tests together, the first test plus the second test is supposed to give us 170 points. So we could drop these parentheses. So we will have X plus X is 2X minus 6 equals 170. We will add 6 on both sides, and 2X equals 176. We divide each side by 2, and X is equal to, this will give us 88. Now remember, X is the second test, but we want to find out what the score is for the first test. So the amount for the first test is X minus 6. So we would substitute in 88 for X, and then subtract 6. So with this first test, 88 minus 6 is 82. So 82 is actually B. All right, now we move on to problem number 5. It says Nelson is twice as old as Maria. 6 years ago, Nelson was 5 times as old as Maria. How old was Nelson 6 years ago? Okay, for this problem here, we're going to have to use the process of elimination for number 5. So what we're trying to do here is we're saying that at this moment, Nelson is twice as old as Maria. So if we do this, Nelson is twice as old as Maria. 6 years ago, Nelson was 5 times as old as Maria. How old was Nelson 6 years ago? Okay, so Nelson is twice as old as Maria. Let's see. So, with that being said, so we look here 6 years ago, we will have to figure out an age that's 5 times as old as Maria. So let's look at it like this. So if we look at A, let's look at A. So we're going to do the current age. Let me write it up here. Current. So the current age, they say that Nelson, let me do Maria. So Nelson would be 2x and Maria would just be x. So now if we do the, let's see, 6 years ago, Nelson was 5 times as old as Maria. So if A is correct, so that means that Nelson would be 5. Then Maria, you have to divide this by 5. Maria would have to be 1. Now, if we add 6 years to both of these, because in 6 years, Nelson's supposed to just be twice her age. So if we add 6 years to Nelson, that would give us 11. But then Maria, if we add 6 years to her, that would give us 7 years. So that doesn't work. So now let's try again the current time. Let's say that Nelson, or I should say 6 years time. Let's say that Nelson is 10. That would mean Maria, since Nelson is 5 times older than her, that means that Maria would have to be 2 years old. Okay, so now, with that being said, we could substitute this value in. So that means that Maria 6 years, so 6 years from now, Nelson would be 10 plus 6, Nelson would be 16. Maria, 6 years from now, would be 8. So Nelson is twice as old as Maria is. So then our answer here would be B, which is 10. Now that is using the process of elimination here. So okay, if we wanted to actually do this as a formula, let's take a look here. So we're going to go back 6 years ago. 6 years ago, Nelson was 5 times as old as Maria. So what we would do, we would put Nelson's age set equal to the answer because we want to find out how old Nelson is. So we have 5x is equal to 5. This is A. We'll divide each side by 5 and x is 1. That would mean Maria would be 1. Now, we could go back up here and do what we did when we added 6. We know if we add six more years here, that means that Nelson would be 11 and Maria will only be 7 years old. And we know that doesn't work. So then we could try the next step. We would do 5x equals 10. Because remember, we're going 6 years ago. We divide each side by 5 and x is 2. So that means Maria is 2 while Nelson is 10, which we did up here. Nelson is 10, Maria is 2. And then we would add the 6 years on of both ages and find out that they work. So the answer is B. So now we go here to problem 6. It says, which of the following is the solution for the quadratic equation 2x squared plus x minus 15 equals 0? Now, with this problem here, we will only need to do substitution. So what we could do, we could go through and substitute each one of these numbers, but I'm not going to do that for the sake of time. So the answer is A, which is -3, but I'm going to show you what you would have done. You would take 2 times -3 squared plus a -3 minus 15 equals 0. So you could do 2 times 9 plus a -3 is the same thing as saying -3. Minus 15 equals 0. 2 times 9 is 18 minus 3 minus 15 equals 0. 18 minus 3 is 15, and we know 15 minus 15 is 0. So our answer here would be A. Now we could have did the factorization that we did in, I believe that was lesson 4. You could do that factorization, but here I would just substitute. I think for a lot of you that would go a lot faster, and I think it would have went faster for me as well. Okay, class, problem number 7. It looks as though I tried a few methods with problem number 7, but the best method would just be to do trial and error. So what we would need to do is figure out how many tickets there are, adult tickets, in order for us to get up to $440 using the amounts that are given to us. Now, with that being said, what we would end up doing is this here. There are a total of 20 tickets. So whatever amount of tickets that we say would be for the adults, we have to subtract that from 20 and use the rest for the children. So instead of going through each one of those numbers, I'm going to go with the answer. The answer is D at 14. So basically, this is how this would go. It's $15 per children's ticket plus $25 per adult ticket. And that's supposed to give us $440. Okay, so if we do it like this here, the adult tickets, I said that it was D. The adult tickets, it'll be 14 of those. So that means it would have to be 6 of the children's tickets. Now, when we put this in our calculator, when you have 25 times 14, that would give us 350. That'll be $350 for the adult tickets, and then the children's tickets would be $90. So we had $90 plus $350, which would give us $440. So that is why D works. Now this right here is a trial and error type of problem. So listen, if you were actually going through this yourself and you were doing this guess and check method, if you use 5, you would do 5 for the adults, then that means that it'll be 15 for the children. If you use 6, it'll be 6 for the adults, 14 for the children. If you did 9 for the adults, 11 for the children. Because remember, what you substitute in has to equal to 20 passes. So that's how we will automatically know how many it was purchased for the children. Now we go here to problem number 8. Problem number 8, it says the rectangular garden below is twice as long as it is wide. If the total distance around the garden is 120 feet, what is the width of the garden in feet? Now, you notice here that we have this rectangle. Now, we could use a couple formulas, but let me do the rectangle here. So we have the length, which is, I put L, which is 2 times W. And then we have the width, which is just the width. Now, we could have made the width X, but we'll just make the width W. Now, we have a couple options. It tells us the total distance around. Now, we know the definition of the distance around is called the perimeter. The perimeter of a rectangle is 2 times the length plus 2 times the width. So the perimeter is equal to, the length is equal to 2W. So it'd be 2 times 2W plus 2 times W. Now, one thing that I didn't put here, but we could put this now, is that the perimeter is 120. So we can add 2 times 2W, which is 4W, plus 2W. So we have 120 is equal to 6W. We divide each side by 6, and 20 is equal to W. Now, they tell us what is the width. So it'd be 20 feet is the width. So our answer here would be B. And that is the final problem from Lesson 5, Chapter 6. I will upload this to YouTube and have a wonderful day.